In embedded and safety critical systems, a software failure is not just a bug, it can become a serious safety risk. That's why structured software testing is a fundamental part of modern product development. Hi, I'm Divya Mahadevappa, an embedded engineer at GSAS Microsystems. In this video, we'll look into the role of software testing in safety critical embedded systems and how TESSY, a dynamic analysis tool, helps the team verify the software behavior with confidence. To understand why testing is so critical, let's first look what actually the software testing means. Software testing is process of verifying that the software behaves exactly as defined in the requirements under all conditions. But testing is not a single activity, it consists of different approaches, each serving a specific purpose. In embedded system, testing becomes especially important because the software directly interacts with hardware, peripherals, and external interfaces. One approach is static analysis, which includes activities like requirement reviews and basic code checks. This method helps identify issues early but cannot validate how software behaves during execution. To verify actual runtime behavior, we rely on dynamic analysis. Dynamic analysis involves execution of software and checking whether it produces the expected output for a given input. This type of testing covers different levels, including unit testing, where single functions are being tested, and integration testing, where interactions between the software components are being verified. Dynamic analysis helps validate boundary conditions, error handling, and overall software behavior, making it essential for safety critical embedded systems. Effective software testing improves overall software quality, reduces development risk, and helps detect defects early. In safety critical domain, it is mandated to comply with industrial standards like ISO 26262, IC 61508, and others. A structured testing approach improves confidence and traceability in software behavior. Performing dynamic analysis manually can be a time-consuming and difficult to manage, especially as a project grows in complexity. This is where TESSY comes in. TESSY is an automated testing tool designed specifically for dynamic analysis of C and C++ softwares. It is widely used for unit and integration testing in safety-critical embedded systems. TESSY automates test case creation and execution, reducing manual efforts and improving consistency. It provides requirement to test traceability and detailed code coverage analysis like statement, branch, and MCDC coverage. With seamless integration into development environment, as TESSY supports around 150 combinations of microcontroller and debugger, TESSY fits naturally into existing workflows. Built-in reporting helps teams meet functional safety and certification requirements. To summarize, the software testing ensures reliable embedded systems and dynamic analysis validates real software behavior. And TESSY provides an efficient and automated way to achieve this. In upcoming videos, we'll explore TESSY workflows and the live demonstration. Thanks for watching. This is Divya signing off.